In this video, I'm going to demonstrate how to write an equation of a linear piecewise function. So multiple pieces that come together, and each of those pieces is linear or straight in structure. And we did learn this in Unit 1, but it's one of the lower assessed skills, and so we included it on the Unit 2 exam, and it will be on next week's Unit 3 exams. It's important to not have the assumption that just because something has been taught to you and you've been assessed on it that you stop learning. If you haven't mastered the concept, you need to continue to learn it until you've mastered it. So again, this will be on next week's Unit 3 exam, and so I'm going to cover how do we write the equation of this. Notice I have three pieces, so I'm going to start with y equals, and I have three parts. It doesn't matter which one I start with, I'm going to choose to do this one. I can see from left to right, by the way, this is rising up, so it has a positive slope. So I'm going to look for where does it cross through good intersection points, and that will help me to identify the slope. Up 2 over 1, up 2 over 1, up 2 over 1. Now why do I keep going with that pattern? Because this is a straight line. So when I write the equation of it, it will be under the form y equals mx plus b. There will be a slope and a y-intercept. And at this point, I don't know what the y-intercept is. So I'm going to go up 2 and over 1. Up 2 and over 1, and I can see that if I extended this, it would cross through the y-intercept at positive 11. So positive 11, and the slope is 2 over 1. So a couple things here. Do you have to put a 1 on the bottom? No, I'm just doing it so that you can see the pattern. You do have to have a 2, and attached to that 2 needs to be the x. Having the x attached to the 2 is going to be able to identify the 2 as the slope. Now where does this occur? Well, if I come down here, okay, it occurs in everything up to -2. Everything up to -2. That means all x's, now think of it this way, it occurs all the way to the left here. So this is an arrow. It also can be used to think of it as an inequality symbol. Okay, so think of this as an arrow. There's the inequality symbol. And now with this -2, I look at this and it was a closed dot, which means it's included as part of the solution set. So to include it, I put a line underneath. This is the easier of the three parts in my mind. Okay, so it's a horizontal line. Now where does it cut through? It cuts through the y-axis at positive 11. Where does it occur? Well, I put x in the middle. It occurs between -2 and positive 2. Okay, so -2 on the left, positive 2 on the right. A lot of students get confused, like, well, how do I put the symbols in there? Okay, think of it this way. It's from this point we're going to the left. See this arrow? So I put that arrow in and then I copy and paste it over again. This means the x values that represent this portion of the graph will be where x's are less than 2 and greater than -2. Now let's go back and look at the circles and closed dots. This means this is not actually part of the solution set, but this point is. It's included. So to include it, I represent it with a line underneath. And finally, I have, again, a straight line, so I'm going to refer to y equals mx plus b. And I'm going to figure out what is the slope of this line. What is the m? So I find good intersection points. Where does it cut through? Where does it cut through the corners? And I understand that sometimes it's harder to look at a screen and determine this versus when you have it on paper. If we were in-person instruction, that would be an advantage. Now, when you are going to identify the slope, you always have to read from left to right, just like we did left to right here, up 2 over 1, up 2 over 1. Well, here from left to right, it's down 1 over 2, down 1 over 2. Now, down is represented with the negative, down 1 over 2. Down 1 over 2. But I can't see what the y-intercept is right now, so I go up 1 and over 2. I follow that pattern, and I can see it would cut through the y-axis at a positive 9. Now we need to illustrate where does this actually occur in the graph. Well, it occurs after I cross the 2. So everything to the right of 2 is where this is happening. Notice that this arrow is like an inequality symbol. So I put that arrow down again, and where does it occur? To the right of 2. This point is not actually included in it. It's an open circle, that's why I do not put a line underneath.